students, today we are going to start from theorem 10.3. In the previous session we have seen the theorem number 10.1 and 10.2. In that we have seen equal chords subtend equal angle at the center, and if two chords subtend equal angle at the center, then they are equal. Now we are going to see theorem number 10.3 and 10.4. These two theorems we need not to do it. Only we shall understand the statement of the theorem, and further we will see the application of the theorems. So first of all, let us see the theorem number 10.3. In this we have given that the perpendicular from the center of a circle to a chord bisect the chord. You can see the figure. We are making the perpendicular from the center O. Okay, we have one center here O, and from the center we are making one perpendicular onto the chord whose name is OM. So here you can suppose OM is a perpendicular from the center to the chord AB. Now this perpendicular will divide the chord AB into two equal parts. That is the theorem statement we have given to us. What is the requirement of this theorem? In this theorem we required, for example, we can say what we need to apply this theorem. So the given you need over here, you required perpendicular OM from center O to chord AB. Okay, so first of all you need here one perpendicular from the center to the chord AB. Then what will be the result you will get over here? The result we shall mention here. The result is given that the perpendicular OM will divide the chord AB into two equal parts. So we can say that AM and BM will be equal and both will be half of AB. Okay, means because since both are equal, for example, if I say that AB is of 10 centimeter, so AM and BM will be two equal parts. They will be both 5 centimeter. So we can say that AM and BM equal, as well as they will be the half of the whole chord AB. So this is the theorem number 10.3. Now let us see the next theorem, which is a converse of the previous theorem. So in 10.4 we have given that the line drawn through the center of the circle to bisect a chord is perpendicular to the chord. Means what they are saying in this theorem, it is just a converse. Whatever result was there in the previous theorem, that will become now given. What they are saying, the line drawn through the center, means we have one line from the center O, okay, and that will be bisecting the chord. So suppose that that line is OM and it is bisecting the chord AB, means we can say that OM is given as OM is a bisector of chord AB. That is given in the question. Okay, means in the form of equation, we can say that AM is equal to BM is equal to half of AB. That is given actually in the question. And what they are saying further? Then they are saying if OM is a bisector of chord AB, it will be perpendicular to the chord. Means here the result you will get OM is perpendicular to AB. Okay, you can check that was the given in the previous theorem. OM was perpendicular to AB. Then we got AM is equal to BM is equal to half of AB. But in theorem 10.4 we can say if OM is a bisector of AB, means AM and BM are equal, means they will be half of AB also, then we can say that OM will be perpendicular to AB. In short, if we compile both the theorem, we can say that if any of the thing we get, then the further we will get in the same manner. For example, suppose if I say OM is perpendicular to AB, I can say AM and BM are equal and they will be half of AB also. And suppose if I say if AM and BM are equal and they are half of AB, then we can say that OM is perpendicular to AB. So these are the two simple theorems. However, we don't require these two theorems right now. These theorems will be utilized in the upcoming exercise. Okay, now I am going to start the first question of exercise 10.3. So let us see the first question of exercise 10.3. See, in this question, what we have given to us, draw different pair of circles. How many points does each pair have in common? What is the maximum number of points common? See, first of all, they are saying you can draw different pair of circles, and they are asking how many points does each pair have in common. How many points will be common over there, and what could be the maximum number of points will be common. So see, I have drawn already here some pair of circles. First, you can see the two circles which are not intersecting at all. Since they are not intersecting, it means that they should not have any common point. Common point means the point should lie in both the circle, that is called as the common point. But here, since both the circle are not intersecting, are not touching each other, so hence they will not have any common point. So first case is both the circles will be not touching each other or will not be intersecting each other. So in that case, there will be no common point. Now here if I say in the second case, when they touch each other, second case is when they are going to touch each other. You can see here, might be it is possible uh, you will accepting here that both the circles are touching at more than one point. Okay, it may possible, but actually, or we can say that theoretically we shall accept over here that if two circles are touching each other, they are going to touch at one and only one point. So remember, if the two circles are going to touch each other, we will assume here that they are touching at only one point. So here that one point I can suppose M. Okay, or you can suppose any other name, but that point will be only one. So in that case they will have the maximum here, and they will have the 1 point common. And if I go to the next and last case, if they are intersecting each other, then in that case the circle will have 2 point common. One is A and second one is B. Now you can try to draw the two pair of circles and find out the number of points common over there. You can find out only out of these three, either no point common where they are not intersecting, or they may have only 1 point common if they are touching each other, or they may have 2 point common, means they will be intersecting at 2 points. Okay, so here you see both the answers we have given. First one is what they were asking to us, how many points does each pair have in common. So either it can be 1 point common over there, or it can be 2 points common in that case. And what will be the maximum number of common points? That will be 2, because we cannot say that here two circles are intersecting at three different points. That is not possible. When circle is intersecting, so they will be intersecting only at 2 points. Okay, we can try to draw circles and try to find out the number of points common over there. The maximum number of points common will be only 2. Okay, now we shall see the second question. I will explain you little later. I am going to start question number 3rd. In the question number 3rd, see what we have given to us. If two circles are intersecting at 2 points, okay, as you can see this figure, in this figure you observe the two circles are given and they are intersecting at 2 points. Okay, then we have to prove that the center lie on the perpendicular bisector of common chord. Now from here the statement is little confusing. Okay, first of all we shall identify who is a common chord here, means it is lying in both the circles, and who will be the line joining the center. So see, first of all I am supposing here this point as A and this point as B. Now you can see clearly the two circles are intersecting at a 2 points A and B, right? Now I will suppose here two more points. This point is P and this point as Q. Here P and Q are the centers. So PQ is a line which is joining the two centers of the circle. Okay, and AB is a common chord. You can see clearly A and B are the common points between the two circles. Okay, sorry. So if you join AB, chord AB lying in the smaller circle whose center is P, and chord AB lying in the bigger circle whose center is Q. Okay, so now what they are saying here, prove that their centers lie on the perpendicular bisector of common chord. Means if you draw the perpendicular bisector of common chord, chord AB we have given here as a common chord, and if I draw the perpendicular bisector, now in this context we can say that the perpendicular bisector will be definitely the horizontal line, because AB is a complete vertical line. So if a chord AB, we need to draw its perpendicular bisector, we need to draw one horizontal line, and that horizontal line we can assume as PQ. So here we need to prove that the line PQ, since line PQ the centers lie already on the line PQ, so we need to remain only one thing, PQ is the only perpendicular bisector of chord AB. So we can say that the line joining the center is the perpendicular bisector of chord AB. Okay, so indirectly what they are asking, actually they are asking, if you join the centers of both the circles, so whichever the line will be formed, that line means the line PQ will be the perpendicular bisector of the chord AB. Now perpendicular bisector means we need to show PQ is perpendicular to AB, as well as PQ divide AB into two equal parts. For example, suppose this point if I give the name as M. Okay, so we can say that the, sorry, once again I will give this point if I give the name as M. Yes, so we can say here AM and BM will be equal. So first of all we shall write down the given things. We'll write down, we have two circles with center P, comma Q, and AB is a common chord. AB is a common chord. Okay, that we are going to suppose. Now we will write down here to prove. So what we need to prove it? We are going to prove PQ is a perpendicular bisector of chord. Okay, that we are going to prove. So why we are proving the PQ is perpendicular bisector of chord AB? That you can read the last few words of the question, you can understand. Okay, now let us start the proof of the question. So in the proof, first of all, see, we shall take two triangles. One triangle is APQ and second triangle is BPQ. So here I am taking two triangles, in triangle APQ and triangle BPQ. Okay. Now in these two triangles you observe, first I am writing here PA is equal to PB. Now how PA and PB are equal? Observe, PA and PB both are the radii of the same circle. Same way we can write down here AQ is equal to BQ. So AQ and BQ also the radii of the bigger circle. So here reason we shall provide radii of same circle. Okay. Now similarly the third thing you observe between the two triangles. Between the two triangles you observe PQ is equal to PQ. PQ is a common side between both the triangles. So here we shall mention common, right? So we can say that therefore triangle APQ is congruent to triangle BPQ. Now these two triangles are congruent with the help of side 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 congruency theorem. Okay, and when these two triangles will become congruent, you see we will get the two angles will be equal. One angle I am supposing here as this angle as angle number 1, and second I am supposing as angle number 2. This is my angle number 2. So I will say here angle 1 is equal to angle number 2. Okay, that is with the help of CPC. Now angle 1 and angle 2 are equal. Once again we shall take the further two more triangles. Okay, so let us see. I am taking here two triangles. One triangle is AMP and second one is BMP. So here first I am writing now in triangle AMP. Now in triangle AMP and triangle BMP. Okay, first of all you observe in these two triangles what we have equal. First you observe in triangle AMP and triangle BMP, PM is a common side, so PM is equal. Second, AP and PB, again they are equal because they are the radii of same circle. And the third one we got equal, that is angle 1 is equal to angle 2. We have proved it earlier. So these three things are equal, and these three things we can say they are forming the side angle side theorem, and we can say that triangle will be congruent. So first of all let us prove these two triangles congruent. So in the triangle AMP and triangle BMP, we can say that first of all we have PM is equal to PM, that is common. Okay. Second, we have equal here AP is equal to BP. Second, we shall write down here AP is equal to BP. That we can say radii of same circle. Okay. And third one I am writing, this one I am giving equation number 1, and I am writing angle 1 is equal to angle 2. This is with the help of by equation number 1. Okay, so now we can say that these two triangles are congruent. Therefore triangle AMP is congruent to triangle BMP. Okay, here we shall write down by side angle side rule. And now if these two triangles are congruent, so we can say that, see, again we shall get here some of the corresponding parts will be equal, whichever are remaining. So here I am supposing the two angles. Observe one angle I am taking here, angle AMP, and second one I am taking here BMP. These two angles will be definitely equal with the help of CPCT. You can draw the two triangles and you can check whether they are corresponding or not. Okay, so they will be definitely corresponding. Second thing you observe, AM and BM will be also one of the corresponding pair of side. So AM and BM will be also equal. So here we shall write down these two things. Now we will have equal over here with the help of CPCT. So first I will write down AM is equal to BM, and second one, angle AMP is equal to angle BMP. That is also with the help of CPCT. These two angles are equal. I am supposing they are equal to X. And now here reason we can give both of them same reason, CPCT. Corresponding parts of congruent triangles. Now see, these two angles we got equal, but if you check carefully, these two angles are adjoining each other, angle AMP and angle BMP. So observe, if you join both the angle, they will form the semicircle. Means these two angles are the linear pair of angles. Okay, angle AMP and angle BMP. You observe both the angles are of the linear pair of angles. So we shall write down further, since angle AMP plus angle BMP is equal to 180 degree. Here reason we can give by linear pair. Okay, now further, angle AMP and angle BMP we can put up here as XX. So both the values I am keeping here, X is equal to 180. So which implies that 2X will be equal to 180, with 2 and 180 will get cancelled, remaining here 90. So we can say that X will be equal to 90 degree. Or we can say that X is 90, means both the angles will be equal to 90, angle AMP and angle BMP, because angle AMP and angle BMP we have supposed here X only, so they both now became as 90 degree. This one I am giving equation number third, and this one AM is equal to BM I am giving as equation number 2. Now see, we are reaching to the part of conclusion. Observe, AM and BM are equal and angle AMP and angle BMP both are equal to 90 degree. We need to prove here that PQ is the perpendicular bisector of AB. Means PQ divides AB into two equal parts. So already we have proved AM and BM are equal. So we can say that PQ is the bisector of AB. Second thing we need to prove, PQ is perpendicular bisector. Means perpendicular also we need to prove it. So PQ should be perpendicular to AB at the point M. So for that already we have proved angle AMP is equal to angle BMP is equal to 90 degree. So we can say that PQ is perpendicular to AB. Already we have proved PQ is bisector. So both the things if we compile, we can say that PQ is perpendicular bisector of chord AB. So that we shall write down as a part of conclusion now. So here we shall say Now, by equation second and third, we can say that PQ is perpendicular bisector of chord AB.